Assalamualaikum and hi everyone. Today we continue our video with last subtopic 4.2 problem interpretation, formulation and solving. Important terms: objective function. Objective function is a linear function to be minimized or maximized subjected to a set of constraints. Means we need to know our objective function. Is it to maximize or minimize? Usually, cost we minimize, profit and revenue we maximize. Next is optimal solution. Optimal solution means we find maximum or minimum value based on our objective function. We found it from the vertices of the feasible region. And these keywords can help you change from statement to inequalities sign. We look example 3, number 1. In preparing for a party, Sally buys 8 loaf of bread costing RM2.30 each and Y bottles of drink costing RM2 each. Based on the information given, we present the following statements in inequalities. We let X equals to loaf of bread and Y equals to bottles of drink. Okay, first, we have Sally buys not less than 5 loaf of bread. Loaf of bread refer to X. So, and not less than means greater than. And since we have put not, so we put equal sign. So, X greater than or equals to 5. Next, we have Sally buys at most 20 bottles of drink. Bottles of drink refer to Y. At most. At most mean less than equal. Why we put equal? Since we have word at. At must put equal sign. So Y less than or equals to 20. And Sally spends more on drink than she does on loaf of bread. Means drink more than bread. So drink is Y. Y greater than bread, X. So Y greater than X. And next, Sally spends not more than RM40 altogether on breads and drink. Cost for bread is RM2.30 and cost for drink is RM2. So we plus all together 2.3x plus 2y not more than. So we use less than equal 40. Next question, number 2. Kenny has 200 liters of high-grade soya sauce and 360 liters of low-grade soya sauce. He wishes to produce 2 new grades of soya sauce, namely M and N. M is produced by mixing high-grade soya sauce and low-grade soya sauce in the ratio 1:3, whereas N is produced by mixing high-grade soya sauce and low-grade soya sauce in the ratio 2:3. Kenny makes a profit of RM3 for every liter of M sold and RM4 for every liter of N sold. The soya sauce are packed in 1 liter bottles. Let X represents the number of bottles of M and Y represents the number of bottles of N. First question, formulate the system of inequalities based on the information given and determine the objective function. So, we need to find system of inequalities and we determine the objective. We create table to put the information. Soya sauce, we know it has high grade soya and low grade soya. And it namely by M for X and N for Y. Bottles M produced by mixing high grade soya sauce and low grade soya sauce in the ratio 1:3. So, M high grade soya is 1/4. Or 4 come from 1 plus 3. So we get 4. Low grade soya is 3. 3/4. Total is 4. And bottles N produced by mixing high grade soya sauce and low grade soya sauce in the ratio 2:3. So total is 5. For high grade soya we have 2/5. And low grade soya we have 3/5. And Kenny makes a profit RM3 for M and 4 ringgit for N. And we also have total. From first sentence, we have Kenny has 200 liters of high-grade soya and 360 liters of low-grade soya. This one refer to total. High-grade soya 200 and low-grade soya 360. We put information in the table to make you easy to state system of inequalities and objective function. Okay, from this table, we can find system of inequalities. We read from X, Y, M, N. So we have 1 over 4X plus 2 over 5Y, and we have total 200. We put less than equal since Kenny has only that total. So we put less than equal. Next equation, 3 over 4X plus 3 over 5y less than or equals to 360. Hence, we put less than equal. Since our x and y refer to bottles, so x and y cannot be negative. So we put x and y greater than or equals to 0. And our objective function about profit. So profit we maximize profit. We put Z, always put Z equals to 3x, 3 ringgit for X and 4 ringgit for Y. That's why Z equals to 3x plus 4y. Next, same question. B, formulate the problem given as a linear programming model to maximize his profit. If question asks to given as a linear programming model, we need to state maximize profit Z equals to 3x plus 4y, and we state subject to our system of inequalities. We have 4. Okay, so if question asks to state in linear programming model, so we arrange like this: maximize or minimize and subject to. Next question, number 3. Find the optimal solution for the following. Optimal solution means we want to find maximum or minimum value based on our objective. Question A, we maximize Z equals to 5x plus y subjected to this system of linear inequalities. Okay, now to find maximum value, we need to sketch the graph. So before we sketch the graph, we find x and y intercept. Okay. First line, we have 4x plus 3y less than or equals to 24. Remember, we need to arrange positive y on the left side. So 3y less than or equals to 24 minus 4x. Then we find the intercept when x equals to 0, y equals to 8, when y equals to 0 and x equals to 6. Next equation, we have x plus 3y less than or equals to 15. We arrange positive y on the left side, so we get 3y less than or equals to 15 minus x. Then we find the intercept. When x equals to 0, we get y 5, and when y equals to 0, we get x equals to 15. Then we take out our graph paper. We put x and y axis. Okay. First line, we have intercept x 6 and y 8. So 6, 8. Okay. Since use sign less than equal, so we use solid line and we label the line 3y equals to 24 minus 4x. Then next line, we have 5 and 15. So we sketch 5 to 15. Use less than equal. So we use solid line. Then we label the graph 3y equals to 15 minus x. Then we have x and y greater than or equals to 0. X equals to 0 on y axis and y equals to 0 on x axis. Then we find the region First line less than equal. So this area. Second line 3y less than equal. So this one. Then x and y greater than 0. So we conclude our feasible region is here. Next, we determine the corner points. Our corner points on the feasible region is here. Point here is 0, 5. Next here, our point is 3, 4. And next here, point is 6, 0. And last corner point is 0, 0. Then we create table. We put our point 0, 5, 6, 0, 3, 4 and 0, 0. Then we put our maximize function z equals to 5x plus y. Then we substitute our point into z. Then we solve, we get 5. Second, we substitute, we get 30. And next, we substitute, we get 19. And last, we substitute, we get 0. Our objective to maximize the function. So, we find the maximum value. Which one is maximum? So, 30 at 0.60. So, we conclude the maximum value of z is 30 when x equals to 6 and y equals to 0. We continue question 3b. We have minimized z equals to 10x plus 6y and subjected to this system of linear inequalities. Okay, first, our function is x plus 2y greater than or equals to 4. We arrange y on the left side. Then we find the intercept. When x equals to 0, we get y2. When y equals to 0, then we get x, 4. Next, we have 3x plus y greater than or equals to 6. We arrange y on the left side. So, we get y greater than or equals to 6 minus 3x. Then we find the intercept. When x equals to 0, y 6. And y equals to 0, we get x 2. Then we take out our graph paper. We put x and y as is. First line, we have intercept 2, 4. x4, y2. So, x4, y2. We use solid line since greater equal. So, solid line. Then we label the line to y equals to 4 minus x. Next line, we have intercept x2, y6. Okay, so same solid line. Since the function use greater equal, then we label y equals to 6 minus 3x. And next, we have x greater than or equals to 0, y greater than or equals to 0. So, x equals to 0 on y as is, and y equals to 0 on x as is. Then, we determine the region. First line, y greater than. Next line, we have y greater equal. Then, we have x and y greater than or equals to 0. Visible region is here. Next, we find the corner points. First corner points is 0, 6. Next, 1.6 and 1.2. And last, we have 4, 0. Then, we create table, put the points. We have 3 points, 0, 6, 1.6, 1.2 and 4, 0. Then our objective, 10x plus 6y. Then we substitute our point into function. Then we choose the minimum value. Since our objective to minimize, so we choose minimum value. Then we state the minimum value of z is 23.2 when x equals to 1.6 and y equals to 1.2. And last question, number 4. A hospital diet requires at least 150 units of proteins, 200 units of vitamins, and 60 units of carbohydrates each day. The hospital purchased two food products, A and B, which cost 40 cents and 50 cents per gram respectively. Each gram of each food product contains a varying number of units of proteins, vitamins, and carbohydrates as shown in the table below. We have food A and food B. We have proteins, vitamin, and carbohydrate. From this table, we let X as food A, B as food Y. First question, formulate the above information as a linear programming model such that the purchasing cost of food will be minimized. So from the table, we can create our system of linear inequalities but formulate it in linear programming model. From question A, is informed that purchasing cost of food will be minimized. So, our objective to minimize the cost. So, question A, we state minimize cost is Z equals to, we check our cost. Cost is 40 cents and 50 cents per gram. So Z equals to 0.4x plus 0.5y. And next, from the table, we find the system of linear inequalities. We use word subject to. From the table, we need to find the total for proteins, vitamin, and carbohydrate. So we put one row with total. From the question, is given protein is 150 units and vitamin 200 and carbohydrate is 60 units. So, our system of linear inequalities, first, we have 3x plus 5y greater than or equals to 150. Greater than or equals since at least 150 units of proteins. So, at least refer to greater equal. Next, we have 5x plus 5y greater than or equals to 200. And last, we have 3x plus y greater than or equals to 60. Then we put x greater than or equals to 0, y greater than or equals to 0. Since our x and y refer to food, so food cannot be negative. We finish question A. Now we go to question B. Question B, find the quantity of each food product to be purchased to minimize cost and state the minimum cost. So we need to sketch the graph, find the region, and find the minimum value. Okay, first we have 3x plus 5y greater than or equals to 150. We arrange y on the left side. So 5y greater than or equals to 150 minus 3x. Next, we find the intercept. Next, we have 5x plus 5y greater than or equals to 200. We arrange y on the left side. Then we find intercept. Last equation, we have 3x plus y greater than or equals to 60. We arrange y on the left side. Then we find intercept. Next, we take out our graph paper. We put x and y as is. First line, we have intercept x 50, y 30. Then we label 5y equals to 150 minus 3x. Our system of inequalities overall have equal sign, so we use solid line. Next function, we have intercept 40, 40. Then we label the graph 5y equals to 200 minus 5x. And last equation, we have intercept 20, 60. And then we label y equals to 60 minus 3x. Next, we determine the feasible region. First line, greater than. Second line, also greater equal. and last line SO greater than equal, then we can conclude our feasible region is here. Then we take out our corner points. First 0, 60. Second point, we have 10, 30. Next point, we have 25, 15. And last point, we have 50, 0. Then we create table. We put our point 0, 60, 10, 30, 25, 15 and last 50, 0. Then we put our objective. Substitute the value. Then we find which value is minimum value. Then we conclude the minimum value of Z is RM70.50 when 25 units of food A and 15 units of food B purchased. So that's all for chapter 4. Thank you everyone.